Hello everyone, welcome to today's webinar on data management analysis using STATA through Digital MEL Hub. It's Alamgir Hossain, founder of Digital MEL Hub, Bangladesh. This learning platform is totally my personal initiative as volunteer task, and it's never responsible of TAB as my present organization. It's my great pleasure that all the amazing M&E professionals of national and international have joined today. And I am grateful to Mr. Abdul Ghaffar for connecting me with Dr. Nuddat Faryasrea, who is today's facilitator. You know, Digital Mill Hub is a virtual open global learning platform, and it's been working with Circle Associate as a learning partner since 2023. Well, now it's time to hear from our guest speaker, Mr. Nozul Islam, Chairman, Circle Associate Limited. I am requesting Mr. Nozul Islam for welcome speech. Over to you, Nozul Bhai.
Okay, thank you everybody. I am Nozul Islam. I am the chairman of the Circle Associates. Circle Associates is a association of the M&E professionals in Bangladesh. It is working from 2019. Actually, it is registration in 2019, but functionally working from 2022. So this is, you can say that this is the chapter, one of the chapter of the M&E professional in the worldwide. And this is belongs to Bangladesh. And we are still working. It's not fully grown, but we are still working on that. So I welcome you all to this webinar on data analysis using STATA. This is a great software. Every MEL professional should learn it. I would like to thank Dr. Nudrat Faryasrea for facilitating this webinar. This is a great opportunity for all of us to learn STATA from her. As you know, the STATA is a powerful integrated software package widely used by the economists, social scientists, MEL professional, public health researcher. Its strength lies in the seamless combination of robust data management capabilities and sophisticated statistical tools. This software is powerful and efficient data management quality. It can clean and reshape data, merge and append data set, create and manage variables, and automated repetitive task. This is a comprehensive statistical analysis package, and it will give you a wide range of method for different type of statistical analysis, from simple descriptive statistics to linear and multivariate analysis. Yeah, it has an econometric focus. Dr. Nudrat is an economist, and obviously she will show you how econometrics is addressing by this software. It has a very or excellent data visualization capabilities. You can generate graphics, chart, various storytelling, graphical presentation from this. So I think I should not take long time with my speech, and Dr. Nudrat Faria is an important speaker for that. I am giving my floor to her, and we all will learn from her. So thank you again for joining this August gathering on analyzing data with STATA. I wish you all for great success from this webinar. Thank you.
Thank you so much, Nodul Bhai, for giving your valuable speech. Honorable Emini and research professional, it's special great momentous to have Dr. Nuddat Faria Shea as a speaker today. I'm honored and grateful to her that she gives her valuable extra effort from her busy schedule. Dr. Shreya is a development economist and researcher specializing in gender equity, financial inclusion, climate change and human trafficking, public health and social economic development in South Asia. She earned her PhD in economics from the University of Kent, United Kingdom, where her research examined the impact of access to finance on rural households in Bangladesh. She has extensive experience in data analysis, quantitative research, project management with a strong interpersonal and communication skill. Previously, she worked at International Finance Corporation, Center for Policy Dialogue, Grameen Telecom Trust, University of Kent, UK, and so on. Presently, she is working as a research director at the University of Pennsylvania, USA since July 2023. Before leaving, I request all of you, please remain unmute during session and you will get open discussion or feedback at the end of the session for 20 to 30 minutes. So keep question or suggestion at your mind. The recorded webinar session and presentation will be circulated through digital WhatsApp group as well as your registered mail. I am requesting Dr. Shreya to start your session. Over to you.
Thank you so much, Alamgir Bhai. It's
Okay.
my pleasure to introduce myself to this great crowd of all MEL researchers and professionals. I am, as Alamgir Bhai has already kindly introduced me, I'm Dr. Nudrat Faria, and I will be conducting a very short webinar on STATA. To be honest, STATA is a very heavy data analytical software, so it's not possible for us to grasp the entire software probably in 2 hours. It would take days and weeks. But I've been using Stata for the past 10 years, given my research background and my PhD. And I would like to share a snapshot of what I have learned, especially in the early days, to get a bird's eye overview of the software, along with a sample data set, as well as a do file, so that you can work on your own in your own time, and you don't get overwhelmed by the complication of a statistical software. Hopefully, we will all learn something new, or at least have a refreshing reminder of what we all know from our past backgrounds. I'm very grateful for giving me this opportunity to Digital Mail Hub, particularly Alamgir Bhai, as well as the Circle Associates and everybody around me today joining us from different parts of the world. Good day to all of you. And let us head to the presentation directly. Okay, I'll turn off my computer and start share. Sorry, I'll turn off my camera and start sharing the screen. May I just request everybody to turn off their microphones, please? Because I feel like it will disrupt our session if everybody's microphones are on. Thank you.
Yes, I will control this. Okay.
Can we all see the screen properly?
Yes, full screen is available.
Okay, thank you so much, Alamgir Bhai. Okay. As we all know, Stata is one of the most powerful statistical softwares. It's widely used in M&E in order to manage the data set that we get from our real life workplace and analyze and visualize the program data. Mostly, Stata is used by social scientists in a different array of topics because it supports the full research workflow. So Stata gives you the platform from getting the raw data from the field to exporting advanced analytical results for helping the world get a real evidence-based, informed policymaking, decision-making process. So how Stata is different from the other software is through the different levels of Stata that helps us get to the real results. It starts from data management, then getting into the summary statistics to descriptive analysis, and it assures 100% impeccable results that assures high quality, as well as it comes with a do file, which is something that's very new to Stata. It was not there in eViews. It is not there in R. Our do file can be shared for transparent as well as repeated results. It's great for collaborative work where you can actually document all that analysis that you have done with your data, as well as share it with your collaborators across the world for repeatable results. Lastly, Stata also allows you for running regression analysis and reporting those results and the data visuals in the form of tables, charts, or graphs for every stakeholder of the project or program so that policymakers can have better decision making. In today's webinar, we will have 5 sections. We'll have an introduction and overview, and a section of data management. Then we'll move on to descriptive statistics, where we see summary tables and we'll cross tabs and data visuals. And then we'll get into inferential statistics, which will have the component of research analysis in terms of regression, and then different kinds of regression that you can run in Stata. And at the end, I will give you at least half an hour of hands-on demo with the real software, as well as a pre-written do file where we'll cover everything that we will see in the sample data set that I've generated for this training. And in this webinar, whatever we are covering will be covered in the hands-on demo. During the hands-on demo, you can ask me any questions that you have or that can arise during the presentation. I would be happy to answer all the questions during the demo session. I will not be taking any questions, unfortunately, during the presentation because I feel like it disrupts the flow. But during the demo, we can have all our questions answered while we're getting to do the software analysis and the regression analysis in practice. Let me get to introduction and overview. As I mentioned before, sorry, I think this is coming in between. Yeah. As I mentioned before, Stata is an analytical software that is used mostly across social scientists. It's very popular in monitoring and evaluation because it gives you an easy platform where you can actually get the data from the field and analyze it without much further ado. It also allows you to clean the data, manipulate the data, get the data in the form and shape that you need for your analysis, as well as produce a written document in the form of a do file, and then get those results across your stakeholders and share the do file for repeatable results forever. It supports data management, statistical modeling, visualization, and reporting. You can also have that feature like many recent softwares where you can export the results directly into your report, and which makes your life a lot easier so that you don't have to sit down and write every number in the report manually. It also has very strong already written pre-commands. So it's a command-based workflow with very user-friendly menus. You can either use the command windows where you can write your own commands and document that in do file, or you can use the menu tabs where you can find each function that you want to run, and you can use those. So Stata is one of the good softwares, and I think it makes it very user-friendly for the social science field, where you can actually document every step that you've taken and every step that you have changed the data and save accordingly, so that even if you come back to the data like 5 years later, where you have probably forgotten what the real data looked like or what you have done to the data, you still have a proper documentation. Once again, can I please request everybody to mute the microphone? Thank you. Where you can create the document of do file and share it across your stakeholders. And even 5 years later, you can come back to the data and you have a very well documented record of what you have done from the start of the raw data till the data that you have produced in your reports or your thesis or your research papers. Stata is also known for great speed and strong documentation, as I've mentioned already. It's heavily used for survey data, impact evaluations, and larger data sets. In fact, Stata allows you to choose your data set size and variable number, and you can get those packages accordingly just to make your life easier in order to use the high quality and heavy data sets. Interface. With the Stata interface, the first thing that shows up, we'll see it in practical in the next slide, is a command window where you can type and run the preset commands that Stata programmers have already written. These commands are usually updated every year, and you can get an updated version from statalist.corp. I have attached the links in at the end of this presentation, so you can have a look at it in your own time. After the command window, you have a results window where your whatever command you have run, the results and outputs are shown there. You have a do file editor, as I've said before, where you can write, save, and run scripts, and you can use those do files. If you writing the do file is very important in Stata because that is your only documentation of what have you done to the data set. So if you write your do file correctly, anybody in this world at any point in time can reproduce exactly the same statistical results and would get to the point where you have collaborative research projects as well as international development programs in the field data and as well as any form of projects that you might want to run. On the right-hand side, we see the variables manager, where it lists all the variables in the data set. There is a data browser where you can actually explore the data in a spreadsheet form. It looks like an Excel, but it's better. There's a review window, which you can see a history. It's actually also called history in the software. And the history tells you what are the past commands you have run. And there's a toolbar for having all those menu tabs that gives you like a shortcut of importing, saving, and managing data. Here is the interface. So as you can see, in the left is the variable manager. You can see the do file editor. There's a results window and a command window. So when we say command, just covering the basics, command is like asking the data to do what you want it to do. So these commands, Stata already has very strong pre-written commands by programmers, but you can also write your own commands through programming in Stata. It is not highly recommended in Stata because programming gets a little complicated in Stata. It's actually recommended to write your own programs in R. But the positive of Stata is that the pre-written commands are so well written that you actually don't always need to. I would say 90% of Stata users do not need to write their own commands. The preset commands are extremely well written and constantly updated. In fact, if there is anything that you don't know how to do in Stata, this is not something that everybody knows. You can actually write to the Stata Corporation and they can help you write a command that works your way. So here's the snapshot of the interface that you will see if you open Stata. Before we get to the hands-on demo, I'll share these screenshots so that we know exactly what we will see once we open the real Stata software. As I said before, this on your left is the history section where you can see the past commands written down. The big chunk of the screen that's taking up all the numbers, that's the results output display. So you can see all the results that will come out once you have written your commands. Below is the command window where you can see that there is a predict y hat command already written. So if you see predict is written in blue, that means it's a preset command already. And you just have to give out your outcome variable that you want to check. On the right, the variables that lists out all the variables that you have in your dataset. It is very important because you can glance through the variable list in a snapshot to see what variables you will use in a particular command. Underneath, there are properties of the variables, which tells you whether it's a string variable, numerical variable, and what is the data set and how many observations you have for that data. And on the top, you'll see that there is the name of the data set. Stata MP17 means that's the 17th version of Stata. Currently, Stata runs the 19th version, and every year Stata comes up with an update. And here, if you see this, what I've highlighted is the directory where the data is stored. As you can see, user Stata documents, that is the folder where the data is stored. And auto.dta is the data file's name. So this gives you a snapshot of what data you're using and what directory you're using. Everybody, whoever will be opening their Stata software will have their own directory, and you can change that directory through your do file. And underneath, if you see file, edit, data, graphics, statistics user, this is the menu tab where you can actually click Once you click data, we'll see it in the hands-on demo. Once you click data, there will be a menu tab of different functions that you can use once whatever you need according to your data needs. This is the data viewer or the data editor where we can explore and look at the data in a different way. As you can see, these numbers on the left, 1 to 36 that we can see is the number of observations, but that number of observations might not be the unique identifier in the data. If there is no unique identifier, you will actually need to create an ID for you specially to make a unique identifier. We'll get into the details of it once we have the hands-on demo. The variables in red are actually string variables. That means they're in text. They don't have any numerical value attached to it. In order to get them to numerical values, we will have to encode them into numerical values. Once again, we'll see that in hands-on demo. And the rest of the data set is here. And all the black numbers are just numerical data already. And you can directly use that for any command, pre-written command, whether that's sum, tab, describe, or regress. We'll see that once we get into the hands-on demo. But meanwhile, this is how the data looks in a data editor. We can see all the variables together, and we can, on the right, we can see the list of variables. And here we can see the properties. And if there is a dot in the data, as you can see with the red arrow here, that means that there is a missing value. STATA does not read missing values in the data. So if there is a missing value or a respondent that is missing some responses, ideally, during data cleaning, we are supposed to drop those respondents if we are analyzing the data that has a missing value. For example, if there is an ID 1, and so the respondent did not respond to the question of what was their income. And if you're running a regression on income, if there is a missing value, STATA will not read that. So in order to get to the point of regression analysis, we need to drop that respondent because that respondent has a missing value in the variable, which is our outcome variable. Again, all of these will be discussed in detail in the hands-on demo. As I said before, the most important thing in STATA is mastering the workflow with do files. So the do file is not just a script of writing your commands. It is actually a definitive record of your analytical journey. It cannot be stressed upon enough how important a do file is. In fact, you can get YouTube videos as well as more content on how to write very efficient do files, because if you have written a very good do file,
which is longevity and
actually makes your life a lot easier, because the do file is the only record and the documentation of what have you done to the data from the raw data in the field till the point that you have come to your results output. So it's very important that you write your do file very clearly. And the good thing about STATA is you can actually put in a lot of headers and comments and extra notes in your do file, and that becomes like a notebook for you, which tells you what have you done to the data, and you can write your own notes that will act as reminders for you to see that what was your thought process behind running this regression. Why did you do that data manipulation? Why did you run that regression? Why did you generate that variable? Why did you create a new group ID? All of these, my guideline is all of these things that you do in the data must be written very properly in a do file, because it makes your life a lot easier. It ensures that your results are transparent and anybody in this world can reproduce those results. In fact, if you want to publish, speaking from my field, if you want to publish in American Economic Association AEA journal, which is the best journal for economics and econometrics, or Econometrica, they will need a very well-written do file with your master data file. They will take your raw data as well as a do file just to see if your workflow has been transparent and if your documentation has been correct from the step of raw data till the final outputs. This is what a do file looks like. So if you can see, the blue things are the commands. Drop if age is below 18. That is a command that you've written in order to drop the respondents who are under the age of 18. But look, if you look closely, there's a star and green lines, and these green lines are the ones that you have written for your own notes. What have you done to the data? You want to describe the variables, you've written the command, you've written the note on top before you've written the command for all the variables that you want to describe. This is very important in order to see what you've done to the data. So imagine if you haven't written these notes and you just have a do file. As you can see, if I regress SBP C.age and the interaction term with gender and every control, but if I don't write the note that I've created in an E-class program that returns marginal means, I might forget later on what have I done to the data or what this regression means in terms of the output. So it's very important that if you create a new variable, if you have done any form of data manipulation to your raw data, that you record it correctly and efficiently in your do file. This do file has to be your best form of record of your research analysis. The next is data management. In data management, today we'll start with importing data, then cleaning data, then labeling data, reshaping data, and merging and appending. Unfortunately, with all the hands-on demo, we will not be able to cover all of it, but I'll try my best to cover as much as possible because again, it's a very short webinar and we don't have enough time to get into all the details, but I'll make sure that you all have a snapshot of what we're doing. So the first thing is importing data. You can actually import any Excel file, CSV, or already formed DTA files into data. It's very easy. You actually can write your command in a do file or use the menu tab to open and import an Excel file. As you can see, if you just click on import Excel and the file name of your Excel, it will come in directly, and all you have to do is select if the first row is your variable name. In the same form, if you want to import a CSV file, which we will cover in the hands-on demo, you can actually use the menu tab or write the command in your do file that import delimited and then the file name, and it will directly import the Excel or CSV file into Stata. Once it's imported, you should be saving the data as a Stata dataset. All the Stata datasets end with .dta. So once you have saved the dataset in DTA, from next time, you don't have to import. You can just open the file name .dta, whatever your DTA file is, and it will directly load the data. So if you have a CSV or an Excel sheet, I think every field data comes in CSV or Excel file. So just save a data version, Stata data version. And once you have this data version, you don't have to go through that importing process every now and then. Once we have the imported data in, we look at the data editor through exploring the data and create, as I've mentioned earlier, you need to create unique identifiers in the data to get your results. What do we mean by unique identifiers? Unique identifier means that every respondent, every person in the survey has to be uniquely identified. You do not, if there are two people in the survey, say suppose me and Alamgir Bhai, you do not want to confuse Alamgir Bhai's responses with mine. So Alamgir Bhai has to get a unique identifier and I need to get a unique identifier in the data set. So if there is no unique identifier, say there is, it can happen. Sometimes it happens in an error. Sometimes it happens in a survey design. It depends on what was your survey questionnaire like. And it can happen that Alamgir Bhai was interviewed twice. So there are two sets of responses, and hence the data has two rows of data for Alamgir Bhai. But then in order to process that data, you need to create a unique identifier to see which survey response do you want to use from Alamgir Bhai, one or two. So create a unique identifier for each. It can happen by choice, it can happen by mistake, but the first step is you have to see if there is a unique identifier. If there is none, then you generate a unique ID. As you can see, gen is the short form of generate. So you can use a unique underscore ID, that's the command, and then have underscore small n means it will count the unique responses in the data set and give you the number of observations of that data set. And again, while we are cleaning data, we generate variables, we drop variables, we keep variables, or we replace variables. For example, if there is a missing value, which is represented by a dot in STATA, we use the command drop if variable double equals to missing value dot. This, what will it do is it will drop that missing value respondent, and you will have a data set without any missing values. And then it's not only replace incorrect values, it can also, the third function that you can see on the slide is replacing values. It does not always have to be incorrect values. It can be something that is you don't want to keep in the data set. For example, if there are sensitive questions in the survey and the person has chosen to not respond it, so usually do not want to respond is coded as 99 in a data set. You can use whatever. I have seen data sets which use 99. I've seen data sets which use 999. I've seen data sets which use 88. Whatever the number is, there is usually in a survey design, there is a certain way that you put in survey options for do not want to respond, don't know, or not applicable. These three are the most common examples that come with these standard numbers like 99, 888, or 999, whatever. It can be whatever. So once you have the survey data set, while cleaning the data, you need to replace those variables because you don't want to keep don't knows in your data, because that will bias or your analysis will not be correct, because you will be, imagine if you have a 99 value in your data, whereas your other response options are 1, 2, or 3. When you run, if you don't replace it or if you don't clean the data properly, but you run the command summarize, it will take an average way higher. That's a wrong average because it has taken the value 99 into account. So we always have to make sure that we get rid of these don't knows, do not want to answer, not applicable, these outliers out from the data. One of the ways to do it is replace the variable with another variable that you're comfortable with. It depends from person to person. It depends from data set to data set. It always depends on how the researcher is running the regression. The next thing we do is label the variables. Sometimes the labeling is tough because you want to put in a very long name for your variables in order to make sense. For example, marital status, you would want to write, or year of marriage, you would want to write the full thing. But in order to run an efficient code on Stata as well as on the convenience on the do file, it's usually recommended to use shorthand or shorter names so that you don't have to type the entire thing every now and then for in the do file or the command window. So we label variables, we define and then attach values. We also encode the data to change from string to numerical or numerical to string according to need, or generate variables that work for us, like treatment and control 1 or 0. We generate binary indicators. As I said, binary indicators means it takes the value of 0 or 1. 1 if a certain thing has happened. For example, treatment and control. If your respondent is in the treatment group, you assign the number 1. If your respondent is in the control group, you assign the number 0, and then label the data as label that variable as treatment. And then reshape. So the next thing in the data set that you can do, or one of the most cleaning commands that we use, or the function that we use, is reshaping. So when you reshape the data, you can see whether, as I mentioned before, if Alamgir Bhai has been surveyed twice, then there will be 2 rows of data. If I want to make it to 1 row, then I have to reshape the data so that all his responses come under one Alamgir Hussain, and I can see all the responses together. Or there can be multiple rows per subject. For example, Alamgir Bhai has responded twice, and then 2 rows will be Alamgir Bhai. And we can use that. That can be the long format. Or if we want, as I mentioned before, if I want Alamgir Bhai's all of the responses in one column, then that will be the wide format where there's just 1 row of Alamgir Bhai with all the responses coming in columns. It's important and absolutely essential for panel data. It is not so important in cross-sectional, because in cross-sectional, we're not going to survey the same person twice. It's only panel when you have when you survey the same respondent multiple times. Just to give you a snapshot or a quick refresher of what is a panel data, what is a cross-sectional data. A cross-sectional data is, suppose if I do a survey just in 2025. I go to a certain group of people and I survey them, and there is no follow-up. There was no baseline before. So that's just one set of data. That's a cross-sectional data. But if I decide that I will conduct a survey this year in 2025, and then I will follow up the same set of respondents after the treatment or the intervention has been done. Working with all the international development programs, we already know that the international development programs come in projects or a programmatic format where there are different interventions that you provide to beneficiaries or participants or groups of people, as you whatever term you use. So if we count those as treatment, then we want to see the baseline before you started the intervention. Say that is in 2025. And then you also want to follow up their outcomes or their responses once the interventions have been over, say in 5 years of time. So in that, if you have conducted 2 rounds of data, once in 2025 and once in 2030, you actually have a panel data set. In that case, you will always have multiple rows per subject, as we were coming back to reshaping, because the same subject or the same respondent will be surveyed twice or thrice or whatever number your survey conduction was. Like if you have conducted the survey baseline, midline, endline, then 3. If you have just done baseline and endline, that's 2. Or if you have done more and more, which is unlikely but still possible, then it will be in that format. So there are multiple rows per subject. But for a cross section, it's only 1 row per subject because there is only 1 round of data collection, and you don't have to think about. It's not that you don't have to think about reshaping, but it's unlikely that you might need to reshape unless you're actually working your data manipulation in a certain way. Merging and appending. Merging is where you have 2 sets of responses for the same respondents. Say one module you have covered about your respondents' educational attainment in details. And then one module you have covered about their employment. So, and then there are two different data sets, 2 different Excel files, 2 different DTA files. So you want to merge those 2. So as you can see, merge 1:1 means there is only 1 respondent in the master file and only 1 corresponding respondent in the dataset 2. But it can, I did not give the example here, but it can be M:1 or 1:M or M:M. There are 3 or 4 versions of merging, depending on whether the master file and the second dataset have uniquely identified respondents or not. But once you merge, it will be 1 respondent and all the other outcomes in the same data set. But when you append, it will be different respondents added to the survey. For example, if I have surveyed in one survey, I'll take 2 random divisions of Bangladesh, say Chittagong and Dhaka. So I have conducted 20 people, a survey of 20 people in Chittagong and 20 people in Dhaka. Then I will append the data set. Once I append the 2 data sets, that means I'm just joining the 2 data sets. My final data set will have 40 respondents, 20 from Dhaka and 20 from Chittagong. On the contrary, when I merge the data set, it will be the same 20 people in Dhaka. One data set must have had, for example, the same 20 people's educational attainment and the same 20 people's employment background. Once I merge them, I'll have my number of observations will still remain 20 because it's the same 20 people, but my outcomes or my columns of data will have increased. They will now include in the same data set, I will be able to see their educational attainment as well as their employment background. So merge in snapshot, the command merge actually increases your columns at the end of the data. in your data viewer or your Excel sheet. The command append actually increases the number of rows because different people are added to your data set. I hope that makes sense. That's the least I could do at the snapshot of time that we have. These are some interesting data manipulation videos that I've attached. These are all YouTube links. You can all go into your own time and look at it. Some of them have lists of videos so that you can have a completely thorough idea of how to manipulate data for data management in STATA. The next thing we'll do is run the descriptive statistics. Descriptive statistics is very important because that allows us to see or explore what our data is like. So it starts with summaries where we can see the mean, median, and standard deviation and number of observation. It is very important because we can get the sample mean. That is the first thing that you do once you have a data set and you've finished your data cleaning. Cross tabs is one of, again, a very interesting thing. Suppose you have a question regarding how many people in my data set are married and can I see them across the gender? How many people, the marital status for the different gender, male and female. You want to have a snapshot, you can do the cross tabs. For visualizations, we talk about histograms, scatter plots, or bar graphs. This gives you visuals are very interesting to see as well as explore data set. And as I've said, missing data, that is a very important key component of data set to see how much missing data do you have. Sometimes if the missing data is too much, then you cannot actually use those outcomes as your outcome variables. I have already spoken about it. Again, a high-level view of your data. The summary gives you the quick mean, median, standard deviation, minimum and maximum of your key variables, as I've mentioned before. The code for summary is summarize. So in short, we can actually write sum in Stata and it runs fine. And in detail, then we can see, we'll see these all in hands-on demo, but I'm just saying, this is the command that you would write in the command window, summarize, and all the variables. Here, they have taken 3 variables as examples, like income, age, and education. We will actually use these 3 variables in our hands-on demo as well, just for your sync. And the second is visual exploration or data visuals. So we can use these box plots or scatter plots or these bar graphs or histograms to better explain our data as well as spot outliers. So if there are outliers, as you can see in the box plot, it's recommended to drop those outliers or at least use a different kind of distribution across the data. If there is missing data, then you need to identify the percentage of your missing data, and in some cases, drop those observations so that you don't get a biased result in your output. Again, I have given all the links here, and you can explore in your own time to get a more thorough knowledge on descriptive statistics. Now, the most important thing is why we're doing this is the regression analysis. This entire process that I've just spoken about is for getting to the final results of the report or the outcome that we want to see. And that comes from inferential statistics. That's the main core or heart of the research. That is the regression analysis. So obviously, we don't have time to delve into each of these in details, but I'll go into an overview where we have different kinds of regression, starting with simple linear regression. In a simple linear regression, we just have one outcome variable. The outcome variable is commonly known as the dependent variable. And in a simple linear regression, there is also one independent variable. For a multiple linear regression, we have one dependent variable, but multiple independent variable. Again, these are all linear regressions. You can run it without manipulating the data, but you can use the outcome variables as is or the dependent variables as is. If you have cleaned the data well and if you have prepared the data correctly for your regression analysis. The next form of regression is there are thousands of forms. There are different kinds of forms. We're just going for the most common ones, simple and multiple, and logistic and probit. For logit regression and probit regression, the outcome variables are not continuous. It's actually binary. So with simple linear and multiple linear, you can use continuous outcome variables where you don't have to generate or change the way the data was collected from the survey. But for a logit or a probit regression, you actually need a binary outcome variable where you assign the value of 0 or 1 um, in the indicator or the dependent variable. For example, if you want to see the treatment, whether it's gender, say your gender is your outcome variable, then if it's male, then you take 1. If it's female, you take 0. Or if it's male, you take 1. If it's female, you take, sorry, if it's a female, you take 1, or male 0. Whatever it is, you do a 0 and 1, and then that becomes your outcome variable and you run probit and logit. So the difference between probit and logit is probit assumes that the error terms follow a normal distribution. A normal distribution, that means there is a sink in the data. The data is actually well balanced. You don't need to, there are not many outliers in the data. So you don't have to manipulate the data in any form before running the regression. For logit, that means that one of the tails or both of the tails are wider in the data set. So the distribution is not normal. The distribution has a bias towards either side or both sides. So we take a logistic distribution. Again, unfortunately, this webinar does not give us a lot of time to delve into these statistical models very deeply, but that's the difference between logit and probit, that the error terms either follow a normal distribution or a log distribution. So for logit, we actually have to assume that the error terms have a log. If we have to run logit, and if you want to do it correctly, the statistics behind, obviously we run the STATA commands with preset commands. That's not something logit, outcome variable, dependent variable, and we're just done. Sorry, logit, dependent variable, independent variables, and we're just done. But what in the background goes ahead is the error terms are following a log value. I hope that makes sense. Again, I have introduced these links in the slides so that if you have any confusion or if you want to know about the difference between probit and logit model or regression analysis for simple and linear, differences between simple and multiple linear regression, then you can watch those videos in your own time and have a better idea or sense of what we're talking about. So we'll go into linear and linear regression in details, starting with simple linear regression and multiple linear regression. As I've said before, for simple linear regression, there is one dependent variable and one predictor. Predictor means independent variable. So one outcome variable, one predictor variable, whereas in a multiple linear regression, you have one dependent variable and multiple independent variables. So the dependent variable is the one that you want to study. So what happens to the income if my research question is such that what happens to my income or what happens to the respondent's income? Which turn does the income take if you're of a certain age and if you have a certain level of educational attainment and if you're of a certain gender? So the question is about what happens to your income, right? So income becomes your dependent variable. And what is that a function of? The the outcome variable or the dependent variable has to be a function of independent variables, which are not dependent on the income. For example, age. Age is not dependent on income. Age is something that naturally happens. My education. What educational attainment I have, we might determine has a relationship with income. But what my income is not dependent on what my education is. Sorry, let me rephrase. What my income is dependent on what my education is, but what my education is not dependent on what my income is. And the same case for gender. So what my income is might depend on my gender, given that there is a gender disparity in income and wage, and there is a massive literature on that. But what my gender is not dependent on what my income is. So whatever is independent are the predictor values, and whatever is the dependent variable is my outcome variable. So age, education, gender in our regression are independent. They're not dependent on any other outcomes or any other factors. But here in this regression analysis, income is our dependent variable. That being said, it is not necessary, or it is important to remember that whatever is my independent variable in a certain regression or in a certain research question will never be a dependent variable in another research question. So it depends on the research question that the researcher is asking. Here, I'm asking the question about what will happen to my income. Hence, income is my dependent and the rest of the factors are independent. If I had questioned what will happen to my education, then education could have been my dependent variable and the other factors could have been my independent variables. So a same variable can become dependent or independent depending on my research question. So do not hold it in fact that whatever we classify as common independent variables will always remain independent, and whatever we classify as dependent variable will always remain dependent. So it all matters on what is the question that we're asking, what is the research question, what is the outcome that we want to study, what is the variable that we want to determine, and that becomes our dependent variable. And then we choose whatever makes sense to us, whatever data we have in our data set, we choose a certain number of variables as our independent variables to model it as a function of our dependent variable. So here is an example of the dependent variable and the independent variable. So if you see in the slide before, we were regressing. This is the command that we write on STATA STATA do file, regress income, age, education, gender, where income is our dependent and age, education, and gender are independent. So we have x1, x2, x3. Y is usually the dependent variable is denoted by y, and all the other independent variables are denoted by x's. So here, x1, x2, x3, because we have three different independent variables, age, education, and gender, and y will be income, which is our dependent variable. So I have written the equation here so that it becomes clear. So y is our dependent variable, and all these x1 and x2 and x3 are our three independent variable that we are studying. This is the STATA regression output that you will get if you run the command regress income, age, education, gender. So the important thing is not running the command. The important thing is analyzing or interpreting the command and interpreting what the results have come in. So if you can see in the visual, x1, x2, x3, as I've said, these are the three independent variables. We are identifying y, so y will not have a value. And these cons is the constant. If all the x1, x2, and x3 are 0, what would still have an impact on income is the constant. And these numbers are the coefficients. So these coefficients, regression analysis coefficients, tell us what direction income will go if there is a change in education, age, or gender. The next column is standard error. The standard error is the deviation in sample mean. So the standard deviation, in other words, is the deviation in each variable's mean, but the standard error is the deviation between how much the sample mean is likely to vary from the true population mean. So we can never survey the entire population, right? We take a sample of respondents as the sample size of our surveys. So we always want, as researchers, we always want the sample mean of our sample to be as close to the as close or as representative as the population mean. So if I survey a certain handful of people across Bangladesh and then take a sample mean, my intention or goal would be to have that sample mean as close as the true population mean of Bangladesh. So standard error tells me how much there is a deviation between my sample mean of my survey sample to the entire population mean. So our goal is to have standard errors as low as possible. So the lower standard error means my sample mean is the closest to population mean. A higher standard error means the sample mean is further away. That means my data is not representative of the population mean. And usually you'll see a correlation between, if you have a high standard error, Then, for example, here, 1.41 for x3. See, this is a higher standard error compared to x1 and x2. And see, the p-value, which tells us about the statistical significance, is insignificant. So that means that if my standard error is very high, it will lead to statistically insignificant results. When we say statistically insignificant, what do we mean? We mean, so there is confidence interval at 95% confidence interval. There are p-values of 5%, 1%, 5%, and 10%. So that means whether these results are valid or not. Statistical significance, in other words, or in very simple terms, mean whether the results are valid or not. So anything above 10% is something that we say that it's not statistically significant. That means the results are not valid. That means we cannot say that x3 or y can be explained by a variation. My dependent variable can be explained by a variation in x3, which is my independent variable. So if you look closely, the p-value for x3 is 0.173. That means it's 17.3%. And that makes it statistically insignificant. That means we cannot say that any variation in y is actually validly caused by any variation in x3. But if you look above 0.00, that means it's valid, statistically significant at 1%. That's the best p-value that you can have. Not always you have 0.00. It's obviously for a real data set, if you run it, it might not be the case, but that is the ideal p-values that you want for your regression analysis. Again, the confidence interval is given here, 95% confidence interval. That means for the 95% of the times, if you run this result, the variation, the coefficient will lie between these ranges. And here on the top, you can see number of observations in your data set and the R square. R square is the goodness of fit. R square tells you whether you have a good fit of the model or not. That means 97%, 0.9752. That means 97.5% of the variation in the data can be explained by the model. That is a very good R square. Usually we say above 70 is a great model, a very good fit. So adjusted R square adjusts for the error terms, and even then 97.05%, that's a great model. So the first things that you need to identify once you have this result output are coefficients, standard errors, p-values, and the R square. So if you have a good fit of the model, if your results are significant here, and you can explain the variation, your standard errors are not too high, you can explain the variation through these coefficients, you have a good regression model. In a snapshot, as I already mentioned, coefficients, expected change in the outcome per unit change in the predictor. As I said, that y will be explained. Any change in y will be explained by a 1 unit change in the x's. Significance, statistical significance is considered through checking the p-values. Typically 0.05, less than 0.05 considered significant. That's actually at 5% level. So a lenient way to do it is 1%, 5%, and 10%. Even 10% statistical significance is widely recognized, but obviously the best is the lowest, 1% or 5%. And as we have discussed before, the adjusted R square is the model fit. It gives us the goodness of fit, and it gives us how much of the variation in the model can be explained by our data. So here I have actually written down in very simple words what each things mean. For example, the coefficient of x1 was 0.928. That means if I keep everything else constant, the value of y, which in our case was income, will increase by 0.928 for a unit increase in education. So with each unit education, for each year of completed education, so say you have completed grade 2 versus somebody has completed grade 3, that is 1 unit of increase in x1, your income will go up by 0.9286648 units. Similarly, holding all factors constant, the value of y will decrease by 2.33. This, whether it's increase or decrease, comes from the sign that is assigned. So if it's minus, then that's a decrease. If it's a plus, then that's an increase. Coming back, holding all factors constant, the value of y will decrease by about 2.33 for a unit increase in x2, and so on and so forth. I have very simply written down what exactly each coefficient will mean. And then I've also attached a link which you can go in your own time and go ahead. So this is, again, summarizing what we have just studied. What are the four things important that you need to identify in your regression output? The first thing is the coefficient. The second thing is the standard error. Standard errors will determine whether it's statistically significant or not. P-values are absolutely important because that determines whether it's statistically significant or your results are valid or not. And then the adjusted R-square, which is the goodness of fit, the proportion of variance in the outcome variable that is predictable from the independent variables. We have all discussed this, so this is just a snapshot summary of what we have just discussed. Now it's time for the practical demo. As I've said, we will have a do file workflow. We will import sample datasets in different format and then open the data editor to explore the dataset, clean the data. I'll do a minimal cleaning because it's not possible for us to do a massive cleaning in such short time. I'll show you some coding and labeling and data arrangement, and then walk through the different exercises such as sum, tab, describe, data visuals, and run some regression analysis. At the end, Alamgir Bhai will share a quiz on refreshing our memory of what we have learned today in the webinar, and then you can check the basics of STATA there and see what if you have grasped the webinar content properly. Now I'm going to share STATA. This is how can you all Alamgir Bhai, can you see the STATA window?
Yes, so for your information, let's check the chat box. Already I have shared do file and create a do file.
Thank you so much. So this is the real STATA software window. And as I've mentioned before, on the left, you can see the history section. In the center, you can see the results section. On the right, you can see the variables and properties. And below, you can see the command window. At this point, we've just started this data. So there is no data set yet loaded. And you can see the menu tab here where you can actually open datasets. So this function of open will only work if you already have a DTA file saved. If you haven't, if you have an Excel or a CSV file, then you need to go down and import from here. As you can see, you can import any form of data that you have at hand. So it can be the most common form, Excel spreadsheet, or a CSV file that we use. But if you have previously worked with SPSS or SAS, you can even get those data files imported into your STATA. And then you have the export tab, where once you have ran all the regression analysis and you have finished your work, you can actually export your output to Excel spreadsheet, or again CSV file, or a doc file, or just text data, where you can just copy and paste in Google Drive or Dropbox or whatever form of document that you're using. And you can print. These are nothing. So again, as I said before, for view, you can see the different tabs or data editor or graph editors. But here is the data tab. From the data tab, if you don't use a do file, which I highly recommend, I never recommend any person or a professional researcher to actually run the commands from here, except for import and export, because if you don't have a do file, you lose the record or documentation of what have you done to the data. So I would suggest, even if you use these menu tabs and you use these commands from here, the commands will come into the history section over here. Please copy those commands and write in your do file so that you have a clear idea of what have you done to the data. Again, see, if you want to combine datasets, you can directly do it from this menu tab, where you can merge two datasets or append datasets, or whatever you want to do, you can actually generating new variables or data editor. You can do everything, or graphs. You can draw the graphs. You can do every command function that you can do in your do file through the menu tab. Again, this has every bit of the binary linear. This is a very detailed, this is one of the good things about Stata. They have very detailed forms of statistical pre-written commands and menu tabs, so you don't always have to know what command exactly to run. If you don't know what command exactly to run, you can either take help from the website Stata Corp, or you can use this menu tab and do your own tweaking to see which command works best. Okay. Without further delay, we will actually start our do file. Here is the do file. As Alamgir Bhai has already said, that he has shared the sample data set that I've created for this webinar and the do file with you. So you can run, if you already have a Stata, working Stata, you can run it with us. Or if you don't have a working Stata, at the end of the presentation, there is a Stata installation guide slides, as well as a document that Alamgir Bhai has already shared probably. You can see a clear guidance on how to install Stata and get to the point that we're using it now. Okay, starting off, I always start off with clear. I'll just run it here so that it's easier to see for all of you. So I always started with clear all and set more off. These make sure that whatever is running in the background of Stata clears up before you start your analysis. Set max var 5000 means set maximum variable to 5000. That's one of the hacks of increasing your Stata's data capacity if you haven't taken the largest data set option for Stata license. See, this is my do file, and I have tried to make sure that I've written everything clearly so that if I come back to it 5 years later or even 5 months later, where, trust me, you will forget what you've done to the data, this document will give you a clear idea of whatever you've done to your data, from importing the data till saving it or exporting your results at the last point. As you can see, I'll just run the command. So I could have, I'll show you, I can copy the command and write it directly in the command window, and this will work. If it's black, then that means it has ran. That means there was no error in the code. See, on the left, the history now has the command that I ran. But if it had an error, say I just said clear. Oh, sorry. Say if I just write something, yeah, this is not a command. So the red writing will always tell you that you have an error in your command. This is something that Stata cannot read. Okay, going back, I will just get the do file started again. So from the do file, you can directly run the code. For example, you just select the command and click on do, and it will run. As you can see at the background, it ran. So I will select all three of these and run. So this command will erase anything that was running in the background, or if there was any updates happening, or if there was any preloaded data already. So clear all will give you a clean slate, and that's one of the good practices to start with. Okay, now importing data into Stata using a CSV file. The first thing before you do that is setting the directory into Stata. So you have to check, you always have to keep your do file and dataset in the same folder in your computer, so that Stata can read the do file and the data together and pull the do file and the data from the same folder, and it does not have to cross manage. So if I import the CSV file and run the command do, see, it has ran, and it tells you that there are 9 variables and 100 observations. So I could have done the same through import and text data CSV, and it would have come to this, and I could have done the same thing. See, select my folder, have the data sets. See, if you can see that there is this CSV file, and I can open that. It will load the data, and I can click OK. yes, see, Stata is asking me because I've already used the do file. Stata is asking me if I want to clear or replace the data in memory. If I click yes, it will again use the same thing. So I just showed you how you can do it through the do file as well as the menu tab. Again, I'll just clear everything and run it again. Import the dataset, CSV file. And now that the CSV file is loaded, I can look at the data editor and look, this is my dataset. I am now looking at my dataset that I've just loaded. It has ID, it has gender, it has age, it has income, it has education, it has district, division. The district and division are based on Bangladesh, so it can be anything your dataset has. The marital status of the respondents, and the year of marriage of the respondents. See, I can see all the variables on my right, and I can see these variables, the data set on my left. If I close the data editor and I bring up my do file again, I save the file in DTA format. So it's the same thing, just instead of .csv, I can save it in DTA so that from next time I can just write the command. I'll just save it now and show you. From next time, I don't have to import the CSV file or do that process again. I can just directly use the DTA file. And now the DTA, so it's the same data set, but now it's just, see, the format has changed and now I have .dta. So that means from now on, I can just go to File, Open, and if I click Open, I can just directly open the DTA file. So let me just tell you here, once I'm running the commands, if you have any question, please raise your hand and Alamgir Bhai will moderate the questions. Okay. While doing this, if you notice, as I said before, if the numbers are in black in a data set, that means they're directly numerical. You don't have to do anything to the numbers. But if they are in red, that means they're just plain text. So you cannot use this text for anything else. So data, Stata will not read it as any numerical values. And say for this, if I run the command sum, which is summarize, and gender, it will have 0. You know why? Because gender is given in male and female in text. So Stata is not being able to read it because it's a string variable. It's in text variable. I have to change it to numerical variable. That is my first step for cleaning this data. See, coding the string variable to numeric variable with value labels, I can just write the command encode gender and generate. Gen is the short form of generate. I will generate a new variable gender2. If you see it, I will run it and you'll see that here, see, I have just generated a new variable gender2. So the color of that variable is blue. That means there is a number assigned at the background of the text. See, male, you will see here, it's assigned 2. Female, the number assigned is 1. Now, if I run sum, gender2, see, I have observations. It's not reading 0 anymore. So Stata can read it. Stata can read the variable now. What it means is something that we'll cover in a bit, but that's what I wanted to show you first. So this is how I encode all of the other string variables into numerical codes. All of this went black. That means the command ran fine. And now see, I have new variables, same variables as here on your left as red. Now they're just coded into numerical values. So now I can use these in my regression. All of these have a number assigned to it at the background, which Stata can read. That is your first step of cleaning once you have your sample, once you have your survey data. So what next I can see, once it's done, I can save see, once your cleaning is done, this is only one form of cleaning. I'm sure with a real data set, trust me, it takes months and months to clean. So, or depending on the size of the data, it takes at least weeks to clean a proper large data set of at least 10,000 observations. There are different steps and different ways of cleaning data. But once you have the clean data, please save the cleaned version and name it the clean version. Again, as I said before, writing your do file efficiently makes your life a lot easier and makes your results reproducible. Okay, now we will start with sample descriptives. So if you want to say in this data set that I have, I want to study the sample which is only the respondents who are married. Suppose we just want to study the respondents who are married. So we need to clean the data accordingly. So here, if you see, the data includes all married, divorced. See, this is the marital status. So divorced, single, widowed, married, it includes all of those, right? So if I want to see or study only the set that includes married sample, I will first need to see what is the value assigned to married. So see, married is 2 here, right? So in the data set or in the do file, here it's 2, sorry. Keep if marital status is 2. That's a single condition. And if I run the data set, you'll see the data set is now only consisting of married sample. This is my married sample. And STATA, by this manipulation, because I said keep only if they're married, STATA has dropped all the unmarried, single, and widowed population from the data set. Now, if we want to also see if they're married and above the age, below the age of, I want to study the sample who are married and above the age of 25. Then I will just refresh the data so that it comes back to the original data set. And I will keep the people who are married and above the age of 25. Then it will keep if marital status is equals to 2. That means only married. And I said above the age of 25, right? So sorry, the arrow is wrong. It's age is greater than 25. That's multiple condition. Previously, it was just one condition. The condition was only married. Here, I have introduced 2 conditions where they're married. They have to be married and above the age of 25. So if I run this, see, my age is all above 25 with the minimum age is 26 and they're all married. See how the multiple condition has worked? Okay. Now, the next thing is if I want to, okay, let me get back to the original data. Every time, because I'm doing a test exercise with you, so I am just doing different things and different data manipulation as showing you different commands like keep or introduce multiple conditions. I'm using this, I'm just refreshing the data content and going back to the original data. Okay, see, these are missing values. So if year of marriage is a good example because obviously if the person is divorced or single, they haven't responded to year of marriage. We don't need the year of marriage for divorced people or single people, right? So these are missing values. So another way to keep only married population is through dropping of these missing value respondents. We will reach the same point as we have done before if we drop if the year of marriage is a missing value. See, it's again 19 observations and only married sample has been remained because we dropped every person whose response was a missing value on year of marriage. That's another way of data manipulation. You can come to the same point through different commands and different ways. I was just showing you the different commands of keep, encode, clear, or drop. Again, coming back to the real data, we will do descriptive statistics as we were all interested. And I'll just type describe and it will describe the entire data set. See, we will see that in our display window. See, when I type describe, it described all of my variables and it told me what variable it is. Like it's a string or a numerical and the value label. Value label is something that I have created, right? I have generated these variables, as you remember, while I was encoding or data cleaning, and these value labels are assigned by the researcher. And the original variable names as such came with the original data set, the collected data set. Describe is only a way to see all the variables together and to get to know whether it's a string variable or a numerical variable. But the most important command is actually sum. So if I summarize, which is extremely important, this gives us the number of observations, mean, standard deviation, minimum, and maximum. So the first thing is ID, which gives us the number of observations. We had 100 people in our original data set. Obviously, the mean is around 50 because it's 100 people. The minimum is 1 and the maximum is 100, given the thing. See, it could not read the gender because the gender was a string variable, but it read gender 2, which we generated as a numerical variable. So it assigned male as 1 and female as 2. So see, the most important thing here, something that we can see is income, which is what is the average income of our sample. The sample mean income is 38,974 BDT, Bangladeshi Taka. And what is the standard deviation? The standard deviation is how much the observations vary from the sample mean, right? So there is a variation of 21,000 from the sample mean. So minimum salary of, minimum income in this data set is 5,247, and the maximum income in this data set is 79,463. Based upon these, the average income is 38,974.344. And the next thing is age. We can see that the average age of our sample is 43 with a standard deviation of 15. And the minimum age, it's an adult sample. So the minimum age is 18 and the maximum age is 70. And see education. For education, it's 3.3. That means, so education attainment is complicated because it depends on how have you coded your data in education. So if it's high school, primary, graduate, or if you have done years of education completed, like grade 1, grade 2, grade 3, it depends on how much of a granular form that you've used in a survey sample. Okay. Not everything makes sense in summary. For example, see marital status. Marital status does not actually show a lot here because 2.61 of mean does not really mean much. But the most important factors in this data set for summarize is age, income, year of marriage, and that's about it. That's about it. There is nothing more. The C district division does not make a lot of sense for a sample mean. So usually numerical values only make a lot of sense for your data set. It depends on what data set you're using. It depends on what kind of regression you will be running. Now, if I want to see if the distribution of educational, what is the distribution of educational attainment across male and female? So if I want to see how much they have studied, how much each or the segments of respondents have studied male and female across the 5 categories of educational attainment. So I can tab the two, it's cross tabulation. So I can tab gender and education and run that command to see a better glimpse. See, this is a very interesting visualization or data exploration. So female, I can see that how many female in my sample. There are 47 female in my sample and 53 male in my sample. And I can see that how many female have graduated, how many female have done just high school, postgrad, primary, secondary, and undergrad, right? So these are the categories, and I can see how many male have done that too. Similarly, if I want to see the same thing with marital status of gender, I can see that. In my data set, how many female are divorced, married, single, widowed? So out of these, see if these numbers, always make sure that your total is always the same. If sometimes your total is not the same, that means your command or data has an error somewhere. It's a good practice to always check if your number of observations match up at the end. So I can see distribution across male and female for their marital status, and it gives me a very good data exploration output. And we can use that in our report in order to report how many people are married, how many female are divorced, or if the rate is higher. So here we can see that there is a higher rate of divorced between male and female, although there is a higher sample as well, but looks like there is a higher married and divorced number of people, but female seems to be higher in single. So these are good practices and good visualizations of data that we can explore and see how our data looks like. Okay, I've already done this replacing or dropping the outcome or missing value. We have done that during dropping the marriage sample, year of marriage. If you remember that I dropped all the missing values by clicking the drop if year of marriage is equals to dot. So you get rid of all the missing values. So another way of doing it is through, look at this. If I want to drop any income that is less than 0, which is an error, for example, if say the enumerator has mistakenly written that income is equals to minus 10,000, which makes 0 sense. So that could be a typing error, that could be a data error, whatever. There is an error. So I can replace the less than 0 with a dot. So in this case, there was 0 real changes made. That means in my data set, there was no value of income less than 0. That means with the income variable, there was supposedly no error in my data set. If there were any, they would make changes, and the Stata would tell you how many changes it has made. Moving on, we can do a simple data visualization of a histogram of income.
Would you check the file data set missing value out of file?
Yeah, of course.
Critically.
See,
Okay.
missing value here.
And after comment, what is your data after comment?
So because there was nothing made, because there was so the command was drop if income is less than 0. If you see from the data, there was no income less than 0. So there were no negative values. So because there were no negative values,
Okay.
Stata did not drop any. But I can again go back and do another thing. We can all see that.
Okay.
See, if I write the command drop if year of marriage here is equals to dot. See, it has dropped 81 observations as Alamgir has requested. We'll see that 81 observations were deleted. Now, if we go into the data, we'll see that there are no missing values for year of marriage, right? The data set shortened and 81 observations have been deleted. So now our data set does not have any missing values.
Perfect. Okay.
Okay, moving on to the next visualization. So I'll do a simple histogram of income with frequency, and see, Stata already has pre-written commands of histogram, box plot, two-way line graph. So these are not commands that we have to write. They're preset commands written. We just have to outline the variables that we want Stata to show us. So here I want to see a histogram of income. And if I click do, and I can see the histogram of income. So here, who have 20,000, they've selected their own bins. You can obviously rearrange your bins if you want to, and you just have to define that in your command. But 20,000, 40,000, so it has done in a escalation of 20,000. So 20 to 40, 40 to 60, 60 to 80. If you remember from our summary stats, our highest income was 79,000. That's exactly why they have done the graph till 80,000. Okay. Now, if we want to do a graph box plot, then we can see a box plot graph. Here is the box plot for male and female for income, right? So we can see that the male income is substantially larger than the female income, and the female income does not even cross more than 25,000 for that matter. And majority of the income mean that we had seen from here. So see the mean income of 38,000 that was driven by the income of males rather than females. It gives us a snapshot of our data. It's an interesting snapshot and something that we should be pointing out. If this was a real data set, we should have pointed out in the report that the sample mean of income is actually driven by the male population rather than the female population, because if I do an average of the female, it would not cross more than 23,000. This is why we do these data visualizations, to give us more information about the data. Now, if we want to do separate graphs for income by age and mean income, then I have already written this command. You can sort. If I sort gender to age, sort is a very good command. I'll show you what sort has done. See, with sort, if I have given age and income, it has listed all the variables, all the respondents in a chronological manner. So if you see, it started with the lowest age to the highest age, and it has sorted the income from lowest to highest. Sorry, it is not income. I think I just sorted. Oh, I just sorted for age and gender. If I do it for age, gender, and income, then we can see the age, gender, and income. See, there was something wrong with my command. If I remove the age, gender, then we can just sort through income. And we'll see that the income has been sorted. See, income started from 6,000 and got up to 76,800. So it has sorted it out chronologically. So sort is a very necessary function because you want to see the data through sorting. You want to explore the data through different levels and chronological levels so that you can see if you want to create category or generate category variables, what categories you should be using. That would depend on sorting your data and having a look at the data. Okay, going back, the next function that we can do is generate a two-way line graph, and for each gender. Oh, sorry, I did not.
Abhay, one question from chat box. In visualization part, can the various values, female, male, etc., be represented by the different color in data visualization?
Yes, it can. You just have to see here. If you look into my do file, here I have just written the sorting the title and X title and what I want the titles to be. You just have to define colors through it. You can, sorry, I'll just go back. See, if you go into options, you can select whatever things you want to do, and you can even write, like, you can choose your own height or graph size or name of graph. You can even write your small contour line legends. You can do whatever you want to do by playing with these options and changing your colors or lines or weights, even sampling weights. You can assign different sampling weights. You can create categories and the frequencies within categories. So that's everything can be done by. So imagine, I'll show you something else as well. Imagine you want to do a color, or you don't know how to draw a different color stata. Let me give you this example. See, if you want to do this, then create graph on stata with different color lines. See, you can just go into stata list. This is one way of showing you how to get help from stata list. So stata has forums in it where you can actually go in and ask for your exact question and see local colors, blue, red, and you can choose your color or do whatever you want to do. So that's one of the ways. If you have a question that you don't know what command to use, you can just go into STATA list, ask your question here, and more chances are these lists are updated every day. So the more chances are that you will find your answer here. Okay.
Okay, perfect.
Now going back to our original thing, we'll do a two-line gender income. And here, sorry, I did something to the data by mistake and my income is gone now. Okay, while showing you, I mistakenly saved a different version of the data. If not, I'll just move away from this visual. Oh, I did not encode. Sorry, it's taking a while because I was talking to you all and changing things in the middle. I didn't realize that I changed the command. Yeah, here it is. So if I want two different graphs and I want to see the mean income by age and gender, then I can do this. Like previously we were seeing graphs in the same graph, male and female. Now we have two different graphs generated for male and female. If we want to do age and gender separately, we can generate two different graphs for the two genders, and also we can do it for mean income or marital status or educational attainment and get these graphs in our reports to have better snapshots of data for each gender, if that makes sense. So as the good thing about Stata is you don't have to do much. There's a two-way line already given in. All you have to do is get the mean income, generate the mean income, and by just specify that you want to do it by gender, and you want to give the title what you want. I want mean income by age and gender. So see, I have written that I want the title. You define your own title of the graph that you want, and you define the title that you want on the y-axis. You define the title that you want in the x-axis. So these are all additions in the command. You can write your own preferences, that what do you want in the x-axis, what do you want in the y-axis, how do you want to title the graph. If I want to title just graph 1, graph 2, I can just write here graph 1, graph 2, and it will write that. Okay. Now, the best part of the thing, these were all data visuals and data manipulation and data management. Now coming back to inferential statistics, the most important and the heart of research, the regression analysis. So I'm going back to the data. I have the clean data again, the full data set, not just the married sample. And I can start my the linear regression, simple linear regression, where I only have one dependent variable and one independent variable. So regress income and age. So I can only see the research output for income and age. Okay. And income and age has a negative relationship connoted by this minus sign in the front. That means when my age increases, my income decreases. With each unit of increase in age, my income decreases by 40.145 units. But look at this. This is not statistically significant. That means my sample, as you can see, the standard error is way higher than my coefficient. That means the random sample that I've generated in this data is not the true representative of the population mean. My sample mean is very far away from the population mean. So my result is not holding. It's not statistically significant. It is statistically insignificant, which means it's invalid. And it is also evident in my R squared. Look, my goodness of fit is very poor. It's almost 0%. So that means that my regression analysis, the data set that I've used, this does not explain the variation in income and age at all. And that is very true, because this is a random data set that I've just generated. It's not real data set. So had it been a real data set, the goodness of fit would be a lot higher. But it's a good example to see the goodness of fit and how to interpret the coefficients. It's very rare that you see a coefficient that small with such high standard errors. And it makes complete sense that your p-value is 77.5%. That means it's so far away, it's like almost 70% above your significance. So it's no way making sense in real data set. Now, if I run a multiple linear regression where I regress income, age, education, and gender, then I can see the output again. See, again, this is a random data set that I generated. So this significance is not low at all. So all the results are statistically insignificant, but it is important to see how the coefficients have reacted. So if your age increases by 1 unit, by each year of age, your income declines by 42.366. If for each year of education, your income declines by 520, and across gender, if you are female, then your income decreases by 381.0177. But none of these p-values are significant. That means all my results are statistically insignificant. And again, that makes perfect sense, because you can look at the adjusted R square and the R square. It's a very poorly fit model. So with the adjusted R square, it's minus 2.84. That means it does not explain even a bit. It's not a good fit at all. It does not explain any variation in my data according to the population mean that I have. This is very common for a bad data set, and because it was a random generated data set, it makes complete sense. Now, if I want to run a logit regression, then I can do a treatment variable and with the same independent variables that I have done. But see, I did it intentionally just to show you that, see, variable treatment not found, because we did not generate any treatment variable. Our data set does not have any variable called treatment. So we need to first generate the variable treatment. I'll generate it with you so that you can see directly from here. Gen treatment equals to 1 if gender 2 equals to 1. See, sorry, I'm in a rush of things, I forgot the equals to. So see, I have generated a new variable, which is treatment equals to 1 if the sample is female, and treatment is equals to 0 if it's male. But because I have not defined it in STATA, it came as a missing value. Now I need to go in and say replace treatment equals to 0 if treatment equals to missing value, and run. See, now all the missing values have been replaced by zeros. Does that make sense? There is many ways of doing it. There is many ways of coming to this generating a variable, but this is the easiest way to do it. And now that I have the treatment, let me run the logit regression. And here is my logit regression. See how we do that? So logit regression needed a binary outcome variable. We generated a binary outcome variable, and then we ran the logit regression. Now, exactly the same way, we have the coefficients and we have the R square and we have the number of observations, 100, and the p-values. As you can see, except for education, education is significant at 10% level because this is 6.9. But apart from that, none of these variables are significant. So that means we can explain the treatment through education, but we cannot explain the outcome variable, which is the treatment variable or the intervention variable, through income and age. I just wanted to show you different ways of regression. So we did linear, multiple, and logit. We can do the same thing in probit and write the same command, probit, treatment. Okay, I can just copy the same thing and show you the probit as well. The only difference is standard errors. Here for logit, it's in logistic terms. For probit, it assumes a normal distribution. But as you can see, the statistical significance still remains the same for education, and the rest of the two are not significant at all. That's how you run logit or probit regression in STATA. And the last bit, how do we export our results? So ideally, I do not recommend exporting results directly from STATA using doc variable. The best way of exporting your results is through LaTeX files. If you use LaTeX, then that's an absolutely amazing feature because it gives you a very professional outlook, and all these professional reports by whether that's World Bank, whether that's other international organizations, or for every published research paper, it has to be written in LaTeX. So all the good journals, we always use LaTeX to generate our tables, but the easiest way is probably to do it in the result document. Okay, I have already generated the result. So here is the results document. See, this is how you get the regression output. In this, you can copy and paste in a doc file, in a Google Doc, in your LaTeX file, whatever file you're using, or Excel, whatever format you're using, you get this table, export, and then you can do it. So you don't always have to do it in this manner. You can do it in every other manner. See, export. You can export to Excel spreadsheet. You can export to CSV. You can export to SPSS. You can export to whatever. I just took the text data form so that it's a free format. You can just copy and do. You can paste it wherever, on whichever format you want. So that's about it. That's our training. Sorry, that's our webinar content. And that's our do file. Alamgir Bhai has already shared the random data set that I've generated and the do file that I've gone through today. I'm sure he will share these slides as well. If you have any other questions, I can answer now.
Thank you, Appa, for your long session. Now open discussion session. There will be a lot of question or feedback on this session, but we will finish by 20 minutes, a couple of times. Please raise your hand one by one. Those who will not get a chance, please write down your opinion, feedback, question, suggestion in your WhatsApp group or email me on to one. So we will take care of your suggestion through the WhatsApp group or others communication. So before that, we will take 5 minutes for knowledge sake. I will provide, already I have provided a chat box. Just we will take 5 minutes to check the knowledge, how we learned from this webinar. So please attend, participate the link and submit the question. That's 6 questions, and I will provide with answer after 5 minutes. So and then after 5 minutes we will discussion. We open discussion.
Sure. Can I stop sharing my screen now,
Sure,
Alamgir Bhai?
sure.
Thank you.
So it's now 10:49. So we will finish 10:55 checkbox, and that we will get 15 minutes because we have a long time that webinar. So thank you for your passion. Still waiting 58, but There was 100 plus 100 participants in this webinar. That was good learning, I think. So I have provided the link, knowledge link at our WhatsApp group or chat box. Please submit your opinion or your answer. Remaining are 3 minutes. We will wait and then go to the open discussion session. Hindul bhai, are you hearing me? Hindul bhai, are you there? Mute. Okay. Thank you very much for your participation. Already I have provide answer question with answer in chat box. You can check with your answer. So now open discussion. Already I have accumulated some question from ChatGPT. as a check box. I will raise one by one. And another thing is that anyone can raise your hand one by one. I will give floor. Within 15 minutes, we will finish this session. So one question from chat box, I'll say, okay. Another participant asked me, can AI replace data? Uh, unmute. Okay. I'll okay. I say yes, sure. Yes, আমি unmute করছি আপনাকে. Technical problem maybe.
Yes,
Yes,
finally.
yes.
Thank
Some question from chat box.
Can AI replace data?
Yeah, first question,
So,
can replace data?
so it's a balance of an answer. The answer is yes and no both. So you can actually you cannot replace data per se in AI, but what you can do is the current format of AI, if it doesn't develop any further in the next year, that's a different story. But at the moment, if you don't have any knowledge of the analytical analysis, like software analysis in data, with just AI, you cannot replace data or you cannot replace your knowledge. So if you know how to run data, if you know how to manipulate the data, you can probably ask ChatGPT or any other open AI platforms to write you a do file for doing certain commands or functions. But it will not, as AI is limited intelligence, you cannot act or it's not limited, but it still has some boundaries. It will not be able to cater to your need completely. So you would need to have at least the intermediate working knowledge of Stata to use AI for your benefit. It can generate do files for sure. It can generate data for sure, but it cannot cater to every researcher's need right now. But again, we don't know where AI is going to go. In a few years' time, coding in a few years' time, it can work that way. But currently, no, it cannot replace data right away.
Okay. Okay. Another
Alamgir?
question. Yes. Yes.
Yeah, now I
You can
want to say
say.
that.
Yes. Another. Yes, you can say.
Okay. Can I say?
Yes. Of course.
Okay. Okay, thank you. These are the very nice session. I actually enjoy lots, and actually the this response of these questions, I actually want to say that the for actually the we are the data player. We actually the handle the many things like in the research and in data management. There are the different perspectives like the diagnosis perspectives and descriptive perspective, predicted perspective, and these things. So what is the actually the data? So for the past data, when actually the exploring the anything, these sort of the things, maybe the AI will be the replaced in the very soon or now. Like the if we asking the AI, please give this spreadsheet, make me the frequency table, make me the percentage. These sort of the things easily now actually the AI already replaced. But in the predict model, but in the so when actually the predictions, when actually the based on my data, uh, will the want to the analyzing the future unseen data when the model feeding, when actually the take the why these things is the happens and what are the issues. So these hot issues already actually the done by the AI. But when actually we asking the why, and what is the actually the our precise intervention will be the, so these things AI never will be the actually the replacing, but they are actually the need to the human judgments, when actually the exploring the why things, so these permutation and combinations, these are the things. So when it is the prediction model, like the in actually the presentation and the last actually they starting the actually the regression model, she say she's on these sort of the things actually the need to obviously based on the human mindsets, but in descriptive part already actually the AI, if you actually the put the any spreadsheet to the chat gpt or DeepSeek and actually asks, give me the EDA model, then he gave the everything, so like the frequency table, bar graph, charts, and also some sort of the hypothesis testing also done. But they cannot do the predictive model. Yeah, these things. Thank you.
Thank you for your thoughts. Have any opinion, Appa,
No, I
related to Hindulbai?
no, I think Hindulbhai was answering to the previous question as well. So
Yeah.
we're in.
Okay. Okay. We will go next question from chat box. May we get the data for free to use?
Unfortunately, you cannot get it in a legal way, but you can get a cracked version sometimes available online or through different organizations sometimes gives you cracked version. I have personally used cracked version in the past, but for the past 10 years in the Western world, you cannot actually get a cracked version.
Okay.
That's
Another question, is it possible to get the latest version of STATA?
absolutely. I just downloaded the latest, I bought the latest version, Stata 19, 2 weeks ago. So you go to the Stata website, you always have the updated Stata.
Okay.
The current
And
version that we played with today was the Stata 19.
okay. Okay. Another three question already covered. Male, female, color. How can we differentiate variable and values in using STATA software? Last question from ChatGPT. How can we differentiate variables and value in using STATA software?
I actually don't understand the question well. So, what do you mean by differentiating variables and values? So, variables are, for example, education, employment, age, income. These are all variables. Values are the numbers, the responses that the respondent has answered for each of those variables, like each of those questions. So I'm not sure if I get the question right, but that's how we differentiate, right? So the
Oh,
question in the survey must have been, what is your income? And so the variable that in the data set that you see is the column called income, and the value is the response that person has given.
okay. Another last question. What security system do you have to protect dataset or STATA software to avoid data loss or hacking into the system?
So Stata does not, to my knowledge, I don't think Stata gets hacked. Your data storage or data security can get hacked. So you can install two-factor authentication for your data storage. For example, for University of Pennsylvania, we always use pen box for data, and that data is stored with everybody's two-factor authentication, and there is only limited number of people that can open the data. So I don't think Stata per se can get hacked, but your data set can. Your data set can be leaked. So Stata does not do that, but if your data storage mechanism is not strong enough, your data can be stolen.
Okay, thank you. No question again. So we will finish. Before that, I want to opportunity to Hindul by say something about the session on behalf of Director of Circle Associate, another Director of Circle Associate. And after talking Hindul by, we will listen from Sriya Appa a little bit something. So, floor to Hindul Bhai, please say something about the session. And
Okay.
okay,
Okay. Thank you, Alamgir. Okay. Just one actually this small information. Strata may using the trial as a student trial 30 days. These are the free. Yeah. you go to the STATA if 30-day, initial 30 days, that's free. Thank you. Actually, these sessions and Alamgir create the nice platform in the globe for many professionals, capacity enhancements. So uh, these are the big platforms for actually the meeting the practitioners, academicians, and also leveraging the learning and sharing the learning. So I think that Alamgir will continue these platforms in long run, and also participant will be the benefitings. And I request to the all participant that we are many professionals, or we are actually the in professions. So please utilize your actually the learning to your work, and also give the feedback to the Alamgir time to time how he can give support to us everyone, because these are the bilateral, not only the one way path. So how can, yeah, these things, so Alamgir maybe the already past the 2 years, so now these are the big things, now so the kids is now actually the grown up, now it is the playing stage. So I believe that all of you actually the give the lots of the feedback to the Alamgir in futures, how he can actually the arrange the more support sessions to all of you. I am also the presenter Maria that she presenting the very nice presentations, and also the informative also. Thanks to Alamgir. Thanks.
Thank you for your nice feedback. So last, I want to hear say something from Shreyapa. What's your feelings after finishing the session? And that we will finish.
Thank you so much, Alamgir Bhai. It has been an absolute pleasure to be sharing the time with you. Thank you to every participant for arranging time on a worldwide weekend day. And I know that across the world, we are joining from different time zones. I am particularly apologetic for the South Asian crowd who are doing it late at night. Thank you so much for attending the webinar. It's my first time working with Digital Mail Hub, and it was an absolute pleasure. Thank you so much, Alamgir Bhai, for giving me the opportunity to do this today. I'm sure we will collaborate more and more, and I look forward to the upcoming webinars as well.
Thank you.
That's
Thank you. Thank you so much. So may I finish this session today?
Yes, absolutely.
Okay.
Thank you for joining
Okay.
us.
Okay. Good day, everybody. So see you soon again within short time. Bye bye. Good night.
Thank you. Thank you very much, sir. Thank you.
Welcome.
Thank you. Thank you. Bye.
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 Thank you. Good night.
Goodbye.
Thank you. Bye bye.
Bye bye.
Bye bye.